In this video, we're going to be looking at the law of cosines. The law of cosines is merely a variation on the Pythagorean theorem, which allows us to find missing measures in oblique triangles. Oblique triangles is another word for just a general triangle, not necessarily a right triangle. However, any formulas that we use for general triangles will also apply to right triangles. We are currently looking at a coordinate grid, and we have a right triangle, triangle ABC. Angle C is a right angle. Side A is 6, side B is 8. And using the Pythagorean theorem, c squared equals a squared plus b squared, we could calculate side C if it wasn't given to us. However, it is possible that angle C could be 135 degrees, bigger than 90 degrees. And look what happens, which is kind of what we would expect. If the angle is bigger, if angle C is now bigger than 90 degrees, we would expect side C to also be larger than it would be, since A and B, these two side lengths, have remained the same. The only thing that's changed is this angle has gotten bigger. As we can see, a final calculation would give us C equals 13.0. We can't use the Pythagorean theorem, but we're going to be using a variation of it to calculate this answer. On the next screen, we're looking at another type of oblique triangle, one which is acute. The 90-degree angle, which was currently here, is now 45 degrees. As we can see, side C is now much less than 10, which is what it would have been for a 90-degree angle. Again, as this angle has gotten smaller, the side opposite has also gotten smaller. We are now going to look at the formula that we use to find these side lengths. On this diagram, I've shown the triangle that we saw previously, and we have this side and the angle in between them. I'm going to label this angle C. I'm going to label this angle A, and I'm going to label this angle B. The side opposite A, the side opposite angle B, and the side opposite angle C. Now C is what we're trying to find, and we realize that if this was a 90-degree angle, that this measurement would be 10 using the Pythagorean theorem. But let's look at the law of cosines formula. For the law of cosines, c squared is going to be equal to a squared plus b squared minus 2 times a times b times the cosine of angle C. This part of the law of cosines should look familiar to us because it's the Pythagorean theorem. However, this part of the law of cosines is what I call the modifier. It's going to change the calculation, the final calculation, one way or the other, to make the side length that we find here bigger or smaller than it would be if it was 90 degrees. So we're going to write this formula, and we're going to plug in what we already know. A squared is 8 squared. B squared is 6 squared. Minus, the 2 is always present in the law of cosines, times A times B times the cosine of angle C, and the angle C is 135 degrees. C squared equals 64 plus 36, which we know is 100, minus, now this all should be calculated at the same time. And what I mean by that is 2 times 8 times 6 is 96, times the cosine of 135, which is negative 0.7071. Again, using your calculator, you're typing in cosine of 135, and this is what's coming back. So at our next stage, we have 100 minus 96 times negative 0.7071. And now we want to do this multiplication. we get c squared equals 100 minus negative 67.9. And subtracting a negative is the same as adding. So we end up with 100 plus 67.9. We get c squared equals 167.9. And for our final step, we're taking the square root of this, and we're getting 12.9, which is approximately what we got on our animation that we just looked at as a side length for C. I'm just going to write that over here, and just to see if it looks reasonable. And it does. It's the biggest angle, it's the biggest side length, so we're okay with this. Now we're going to be looking at this oblique triangle that has a 45-degree angle for angle C. Use the law of cosines again. We're trying to find this missing side length, C. So we're saying c squared equals a squared plus b squared minus 2 times a times b times the cosine of angle C. So really a lot of the numbers here have remained the same. 8 squared plus 6 squared, which is going to give us 100, minus 2 times 8 times 6, which once again is going to give us 96. However, the cosine of angle C right now, the cosine of 45 degrees is positive 0.7071. So when we do this multiplication now, we get 67.9, and we're actually going to be doing our subtraction here. So we get c squared equals 32.1, and taking the square root of 32.1 gives us what this side length is now equal to, which is 5.67 or 5.7. Reasonable answer, because this angle is smaller than it was. What the law of cosines does is it really kind of works in that it takes the cosine of an angle, and if an angle is less than 90 degrees, the cosine of that angle in this quadrant is going to be a positive number. So when you subtract 2 times a times b times the cosine of angle C, since this is always positive, the whole answer is going to get smaller. When, however, you've got an obtuse angle, as we did on the previous page, say 135 degrees, the cosine of that angle ends up being negative. And let's see how that worked in the previous example. When you're subtracting a number times a negative number, you end up with a subtraction of a negative, which ends up adding that value in, making your answer larger than it would be, which is what makes sense. If the angle is bigger than 90 degrees, you expect that the whole answer is going to be bigger. This is a brief example of one of the uses of the law of cosines.